There's something peaceful about sitting in a dark room with just one light on. Maybe it's a lamp in the corner. Maybe it's the glow from a screen. Or moonlight coming through a window. Whatever it is, the light feels immediate, present. It feels like it's simply here, with you, in this moment. And in a way that's true, but in another way, in a way that's easy to forget. The light you're seeing right now is not from now. It's from the past. Not the distant past, not always. Sometimes just a fraction of a second ago, but still see the past. This isn't something we usually think about. Light feels instant. You flip a switch and the room fills. You look at something and you see it. There's no delay that we can feel, no waiting, but light does take time to travel. It moves incredibly fast, faster than anything else we know, but it still moves. And because it moves, it takes time to get from one place to another, which means that every single thing you see, you're seeing as it was, not as it is. You're always looking backward, even if only by the smallest measure. This is true for everything. The wall across the room, your hand in front of your face, the stars outside, all of it. We live our lives surrounded by light that has travelled to reach us, and the farther away something is, the older its light becomes. Right now, without moving, without doing anything, you are seeing light from different moments in time, all arriving at one, all blending together into what feels like a single present. But it isn't a single present. It's a collection of pasts. Some of those pasts are so recent they feel like now, a billionth of a second old, a millionth, so close to the present moment that the difference dissolves. But some of those pasts are older, much older. If you've ever looked up at the night sky, and you probably have, you've seen light that left its source years ago, decades ago, centuries ago. You've seen stars as they were before you were born. You've seen galaxies as they were before humans walked upright. You didn't have to do anything special to see it. You just looked up. The question we're going to explore tonight, slowly, gently, without any rush, is this. How old is the light you're seeing right now? Not in a complicated way. Not with formulas or measurements that don't mean much in the quiet of a dark room. Just in a way that lets you notice something you've been living with your entire life, but maybe never stop to feel, because once you start to notice it, everything looks a little different. Not worse, not better, just different. The light around you becomes softer somehow, more patient. It has travelled so far to reach you. It has crossed distances you can't fully picture. And it arrives so gently, so quietly, that you barely notice it's been on a journey at all. We'll begin close to home, with the light that's nearest to you. The light in this room, or the light from the sun, or the light from the moon. And then slowly we'll move outward. There's no hurry, the light has already waited this long. When you turn on a light, it feels immediate. You press the switch and the room changes. Darkness becomes brightness. There's no gap that you can sense, no moment where you're waiting for the light to arrive. It just happens. And for most of our lives, that's all we need to know. Light is fast. Light is there when we need it. We don't have to think about how it gets from one place to another, but it does get from one place to another. It travels, and because it travels, it takes time. Not much time usually, not in the spaces we move through every day, but some time, always some time. Light moves at about 300,000 kilometers per second. That's roughly 186,000 miles per second if you prefer. We're not going to dwell on the number. It doesn't really matter. Not in the way numbers sometimes do. What matters is this: light is the fastest thing we know of, and yet it still has a speed. It still has to cross distance. And distance takes time. Even here in your room, the light from a lamp has to travel across the space between the bulb and your eyes. It's a tiny distance. A few feet maybe, a few meters. The light covers that distance in a few billionths of a second. So small that it might as well be instant, but it isn't instant. It's just very, very close. Now think about sunlight. The sun is far away, much farther than anything else we see during the day. It's about 50 million kilometers from Earth, about 93 million miles. At light speed, that distance takes a little over 8 minutes to cross, which means the sunlight touching your skin right now, the warmth you feel on a bright afternoon, the glow that lights the sky, that light left the sun 8 minutes ago. You're not feeling the sun as it is. You're feeling the sun as it was, 8 minutes in the past. If the sun suddenly vanished, if it blinked out of existence in an instant, we wouldn't know for 8 minutes. For 8 minutes, the sky would still be bright. The world would still be warm. Everything would seem normal. And then, all at once, the last of the light would arrive and the sky would go dark. This won't happen. The sun is stable. It will keep shining for billions of years. But the fact that it could happen, that there's a delay built into everything we see, changes how we might think about light. It's not just illumination, it's information. Information that takes time to reach us. Every time you see something, you're receiving a message that was sent a moment ago or many moments ago, depending on how far the light has travelled. You don't experience the world directly. You experience echoes of it, echoes made of light. This is true for everything, not just the sun, not just distant things, the face of someone sitting across from you. The light reflecting off their face takes a tiny fraction of a second to reach your eyes. You're seeing them as they were a few nanoseconds ago. It's such a small delay that it doesn't matter in any practical sense. You're still seeing them in what feels like the present. You're still sharing the same moment. But technically you're not. You're always just a little bit behind. We all are. We live in a world where the present moment is always slightly out of reach. Always just ahead of the light that brings it to us. And the farther away something is, the farther behind we fall. The sun, 8 minutes. But what about the moon? What about the planets? What about the stars? Each one is a little farther. Each one shows us a past that's a little bit older. And as we move outward, gently, slowly, we'll start to see just how old the light around us really is. Let's stay here for a moment, in the room where you are. Because before we go out into space, before we think about stars and planets and distances we can barely imagine, it helps to notice what's happening right here, right now, or what feels like right now. Look around if you'd like, or just imagine it. If your eyes are closed, there's a wall, maybe a ceiling, furniture, objects resting on surfaces, your own hand if you hold it up. All of these things are visible because light is bouncing off them and travelling to your eyes. That's how we see. Light reflects off surfaces, carries information about colour and shape and texture, and then enters our eyes where it's translated into an image. It happens so smoothly that we don't think about the steps. We just see. But each of those steps takes time. The light leaves the lamp or comes through the window. It travels across the room, it strikes the wall, it bounces off, it travels again. This time toward you, and then it reaches your eyes. All of this happens in less than 1/100th of a microsecond for most rooms. So fast that the delay is meaningless, but it's still there, which means that when you look at the wall across from you, you're not seeing the wall as it is in this exact moment. You're seeing it as it was a few billionths of a second ago. The light that left the wall is already old by the time it arrives. Your hand, if you're looking at it, the light reflecting off your skin left a few nanoseconds in the past. Everything you see is in the past. Not by much, not by anything you could ever feel or notice in daily life. But in a literal sense, you have never seen the present moment. You've only ever seen moments that have already happened. This might sound strange at first, or maybe it sounds like it doesn't matter, and in one sense it doesn't. The delay is so small that it changes nothing about how we live. We move through the world just fine. We catch things when they're thrown to us. We talk to each other. We navigate spaces without confusion. The tiny gap between the present and what we see doesn't interfere with anything. But in another sense, it matters a great deal, because it tells us something about the nature of perception itself. We think of seeing as direct, immediate, as if our eyes are simply open windows to the world showing us what's there, but they're not. They're receivers. They're catching light that has travelled, light that carries information from the past, however recent that past might be. We don't see the world. We see light's memory of it, and that memory takes time to arrive, even here, even in the smallest, quietest spaces. The room you're in right now is filled with light from different moments, all arriving at slightly different times, all layering together into what feels like a single unified present. But it's not unified, it's a mosaic of pasts, so close together that they blur into something we experience as now. This is true even when you look at yourself. If you glance down at your hands, the light reflecting off them has already left by the time you see it. You are always seeing yourself as you were, not as you are. The difference is impossibly small, unnoticeable, but it's real. You exist in a present moment that you can never quite see. By the time the light reaches you, the moment has already moved on. And this is just the beginning, because the room is small, the distances are short, the delays are tiny. But when we step outside, when we look up at the sky, at the moon, at the planets and stars, the delays grow, the light gets older, and the past we're seeing starts to stretch backward. Not in nanoseconds, but in seconds, minutes, years. We'll go there next, gently, one step at a time. For now, it's enough to notice that even here, even in the smallest space, light is always travelling, always arriving from a moment that's already gone. If you go outside on a clear night and the moon is up, take a moment to look at it. It's beautiful, isn't it? Calm, steady, always there even when we forget to notice. The moon doesn't make its own light. It reflects the sun's light back toward us. Sunlight strikes the moon's surface, bounces off the dust and rock, and travels across the space between the moon and Earth. And that space is larger than it seems. The moon is about 384,000 kilometers away, roughly 239,000 miles. It feels close in a way, close enough to see details, close enough to watch it change shape over the course of a month, close enough that we've sent people there and they came back. But it's not close in terms of light. Light from the moon takes about 1.3 seconds to reach us, a little over a second, not long in the grand scope of things. You could count to 2 and the light would have made the journey. But it's long enough to notice if you think about it. Long enough that the moon you're seeing is not where the moon is, it's where the moon was a second ago. If you're standing outside looking up, you're seeing the moon's past, not its present. The present moon, the moon as it exists in this exact moment, is somewhere else in its orbit. Not far, just a little bit ahead, but ahead, out of reach. You will never see the moon as it is right now, only as it was. This is true every time you look up, every night, every phase. The full moon you see is the full moon from a second ago. The crescent moon is a second old. Even the moon landing footage, the images transmitted back to Earth in 1969, those signals took 1.3 seconds to arrive. Mission Control in Houston wasn't hearing the astronauts in real time. They were hearing them as they were, a second earlier. Every word, every step, every moment delayed. Not by much, but delayed. There's something peaceful about this in a way. The moon doesn't rush, it doesn't need to. It moves through space at its own pace, reflecting light, travelling in its slow orbit around Earth, completely unbothered by the fact that we're always seeing it a little bit late. It's been doing this for billions of years, long before anyone was here to look up at it, and it will keep doing this long after we're gone. The light will keep travelling, the delay will remain. The moon will keep showing us its past second by second, night after night, and we can simply receive it. We don't have to do anything with this information. We don't have to solve it, or fix it, or figure out what it means. We can just notice. Notice that when you look at the moon, you're looking backward through time. Not far, just a little, but enough that the present moment and the moment you're seeing are not the same. This is the first step outward, the first place where the delay becomes something you can almost feel if you pay attention. 1 second, one small gap between what is and what we see, and it only grows from here, because the moon is our closest neighbour. Everything else in the night sky is farther away, much farther. The planets, Venus, Mars, Jupiter, Saturn, they're all out there, shining in the dark, sending us light that's older than the moon's light. Minutes old instead of seconds. And beyond them the stars, light that's years old, decades old, centuries old, all of it travelling toward us, patiently, quietly carrying the past across unimaginable distances. We'll move outward now, slowly, the way light moves, 1 step at a time. But for now the moon is enough. 1 second of delay, one small reminder that we're always looking backward, even when we're looking up at something familiar, something we've seen 1,000 times before. The moon is still there, still glowing, still showing us where it was, not where it is, and that's perfectly fine. There's no rush to catch up, the light will keep coming. We just have to be here to receive it. The planets move slowly across the sky, not in a way you'd notice from night to night, usually, but over weeks, over months they shift, they wander through the constellations, which is why the ancient astronomers called them wanderers. They look like stars if you don't know what you're looking for, but they're different. They don't twinkle quite the same way. They hold their light a little more steadily, and if you watch them long enough you'll notice they're not fixed. They're travelling. Just like the moon, the planets don't make their own light. They reflect the sun's light back toward us. Sunlight reaches them first, bounces off their atmospheres or surfaces, and then continues outward, some of it in our direction. And because they're farther away than the moon, that light takes longer to arrive. Venus is the closest planet to us, at its nearest, about 40 million kilometres away. Around 25 million miles. The light from Venus takes a little over 2 minutes to reach Earth. 2 minutes. When you see Venus shining in the evening sky, bright and steady, often the first star to appear after sunset, you're seeing it as it was 2 minutes ago, not as it is now, 2 minutes in the past. If something changed on Venus in this exact moment, if a storm formed or the light shifted, you wouldn't see it for 2 minutes. You'd still be seeing the Venus from before the change. The old Venus. Mars' father. At its closest, Mars is about 5 million kilometres away. At its farthest, over 400 million. The light from Mars can take anywhere from 3 minutes to 22 minutes to reach us, depending on where Earth and Mars are in their orbits. 22 minutes. That's not a small amount of time. That's long enough to boil water, long enough to take a walk, long enough to have a conversation. And yet when you look up and see that small reddish dot in the sky, it feels immediate, it feels present, but it's not. It's the past. Mars as it was 20 minutes ago, or 10, or 5. You're seeing a Mars that no longer exists in that exact form. It has moved on. The dust has shifted, the light has changed, the planet has continued in its orbit, but the light hasn't caught up yet. Jupiter is farther still, about 70 million kilometers away when it's closest to us, nearly 500 million miles. Light from Jupiter takes between 33 and 54 minutes to arrive, depending on where both planets are. Nearly an hour at times. When you see Jupiter in the night sky, large and bright with its faint moons visible through even a small telescope, you're seeing it as it was almost an hour ago. You're seeing a Jupiter from before you started watching. A Jupiter that existed while you were having dinner, or getting ready for bed, or sitting down to rest. And Saturn, beautiful ringed Saturn, is even farther, over 1 billion kilometers away at its closest. Light from Saturn takes about an hour and 20 minutes to reach us. An hour and 20 minutes. If you look at Saturn tonight, you're seeing it as it was earlier this evening. Before the sky got dark, before you came outside, the Saturn you see is not the Saturn that exists right now. It's a memory. A memory carried by light, crossing the cold space between us, arriving late but arriving still. This doesn't make the planets any less real, doesn't make them less beautiful. If anything, it makes them more remarkable. Because these small points of light, these quiet wandering stars, they've been travelling for so long just to reach us. The light has crossed distances we can barely imagine, carrying information from worlds we'll likely never stand on, arriving here, now, in the moment, so that we can look up and see them, but as they were. And that's enough, is more than enough, because even though we're seeing the past, we're still seeing something true. The planets are still there, still moving, still reflecting light. The delay doesn't erase them, it just means we're always a little bit behind, always catching up to a present moment that stays just out of reach. And the farther we look, the farther behind we fall, because the planets are only the beginning. Beyond them, farther out, the stars wait. And the light from the stars is not minutes old, it's years old, decades old, centuries old. We'll go there next, slowly as always. One step farther from home, one step deeper into the past. The stars feel distant in a way the planets don't. The planets are part of our neighbourhood, our solar system. They orbit the same sun we do. They're neighbours even if they're far away. But the stars are something else. They're other suns, other points of light, burning far beyond the edge of our small corner of space. And the nearest one, after our own sun, is still unimaginably far away. Alpha Centauri. It's actually a system of 3 stars orbiting each other, but from here they look like one. Alpha Centauri is about 4.37 light years away. A light year is the distance light travels in 1 year, moving at 300,000 kilometers per second, never slowing, never stopping for an entire year. That's about 9.5 trillion kilometers, nearly 6 trillion miles. It's a distance so large that it stops meaning much in any practical sense. We can say the number, but we can't really picture it. What we can picture is this. The light from Alpha Centauri takes 4.37 years to reach us, 4 years and a few months, which means that when you look at Alpha Centauri in the night sky, if you're in the southern hemisphere, Where it's visible, you're seeing it as it was over 4 years ago. You're seeing it as it was before the last presidential election, before the pandemic ended, before countless small moments in your own life that have come and gone. The light left that star over 4 years ago, and it's been travelling ever since, crossing empty space, moving through the dark, heading in our direction, carrying information about a star that no longer looks exactly the way we're seeing it. If Alpha Centauri suddenly exploded tonight, if it went supernova, flared bright and then faded, we wouldn't know for over 4 years. For 4 years, we'd keep seeing it as it was, steady, calm, unchanged. And then one night, the light from the explosion would finally arrive, and the star would change, not because it changed in that moment, but because the news finally reached us. Sirius is another close neighbour, the brightest star in our night sky, visible from almost anywhere on Earth. Sirius is about 8.6 light years away. The light you see from Sirius tonight left that star in 2016, nearly 9 years ago. 9 years of travelling, 9 years of crossing the empty space between stars, 9 years of moving toward us, carrying the past. When you see Sirius shining in the winter sky, you're seeing it as it was 9 years ago. Before things in your life were the way they are now, before certain people came into your life or left it, before decisions were made, paths were chosen, routines were built. The light is older than some of the memories you carry, and it's still one of the closest stars. Most of the stars you can see with your eyes, without a telescope, just looking up on a clear night, are farther than Sirius, much farther. Betelgeuse, the red star in Orion's shoulder, is about 550 light years away. The light from Betelgeuse is 50 years old. It left that star in the 1470s, before Columbus sailed, before the printing press spread widely, before the Renaissance reached its height. That light has been travelling for over 5 centuries, and it's still arriving every night for anyone who looks up. Rigel, the blue star in Orion's foot, is even farther, about 860 light years away. The light from Rigel left in the year 1165, the Middle Ages, a time before most of the world we recognise existed. And yet the light kept moving, kept travelling, kept crossing the dark, until now, until tonight, when it finally arrives here, and you see it without even trying. Some of the stars we see no longer exist. They've already died, collapsed, exploded, faded away. But their light is still travelling, still crossing the distances between where they were and where we are, still arriving night after night, showing us stars that are already gone. We're seeing ghosts in a way, not in a frightening sense, not in a sad sense, just ghosts, echoes of light from objects that have finished their lives but whose light hasn't finished its journey. This is what it means to look at the stars. You're not looking at the present sky. You're looking at a sky made of history. Every star is a different moment in the past. Some recent, some ancient. All of them arriving here together in what feels like a single moment. But it's not a single moment. It's thousands of moments layered on top of each other, all visible at once, and the farther out we look, the older the light becomes. Beyond the nearest stars, there are stars thousands of light years away, tens, thousands, and beyond them galaxies, entire galaxies filled with billions of stars so far away that their light has been travelling since before humans existed. We'll go there soon, but not yet. For now, the stars are enough. These distant suns shining steadily, sending us light from the past, light that we can see simply by looking up. Nothing complicated, nothing difficult, just light. Old light, patient light, still travelling after all this time. Most of the stars you can see on a clear night are within a few thousand light years of Earth. That sounds like a lot, and it is, but it's only a small part of our galaxy. The Milky Way, our galaxy, is about 100,000 light years across. 100,000, which means there are stars in our own galaxy whose light takes 100,000 years to reach us. Stars we could never see with our eyes alone, but that exist nonetheless, shining in the far reaches of the spiral arms, sending out light that won't arrive here for tens of thousands of years. And there are stars whose light left so long ago that the Earth was different when it started its journey. 50,000 years ago, humans were just beginning to spread across continents. There were no cities, no writing, no agriculture, just small groups moving slowly, adapting, surviving. And somewhere far away, light left a star and began travelling toward a planet those people would never know existed. That light is arriving now, tonight, reaching Earth after 50,000 years of travel. If you had a powerful enough telescope, you could see that star. You'd be seeing it as it was when our ancestors were living in caves, telling stories by firelight, looking up at a sky that held the same stars we see now, the same old light still travelling. Some stars are even farther, 100,000 light years away. The far edge of the galaxy. The light from those stars left before modern humans existed, before our species took the shape it has now. The light has been travelling longer than we've been who we are, and it's still moving, still crossing the dark, still making its way here. We won't see most of those stars. They are too far, too faint, but they're there, part of the same galaxy we live in, sending light across distances so vast that the journey takes longer than entire chapters of human history. And some of those stars, many of them probably, don't exist anymore. They've run out of fuel, collapsed, exploded, faded into remnants, but we'll keep seeing them for thousands of years. Because the light is still travelling, still carrying the image of a star that's already gone. There's something quietly astonishing about that. Not dramatic, not urgent, just astonishing. That we can look up and see stars that no longer exist. That the sky is full of light from objects that have already ended. That the past is still visible, not because we're doing anything special, but simply because light takes time. And beyond our galaxy, the light gets even older, much older. Because beyond the Milky Way there are other galaxies, billions of them, each one filled with billions of stars. And the light from those galaxies has travelled even farther, across distances we can barely begin to imagine. We'll go there next, to the galaxies, to light that's millions of years old, to a past that stretches back before anything we recognise. On a dark night, far from city lights, you can see a faint band of light stretching across the sky. The Milky Way, our galaxy seen from the inside, billions of stars so far away that they blur together into a soft glow. It's beautiful, but it's not the only galaxy. There are others, countless others, and some of them are visible even without a telescope. Andromeda is the closest large galaxy to us. If you know where to look and the sky is dark enough, you can see it with your eyes alone. It appears as a small, fuzzy patch of light. Nothing dramatic, nothing bright, just a gentle smudge against the darkness. But that small smudge is an entire galaxy. A galaxy containing roughly 1 trillion stars. Planets, dust, gas, entire solar systems, orbiting stars we'll never see up close, and it's 2.5 million light years away. 2.5 million. The light from Andromeda. The light you see when you look at that faint patch in the sky left that galaxy 2 million years ago, long before humans existed, before our species had evolved, before our ancestors had left the trees. The light left Andromeda and began travelling through the vast emptiness between galaxies, moving steadily, patiently for over 2 million years. And tonight it arrives here. It reaches your eyes. You see a galaxy as it was in the distant past, not the Andromeda that exists now. We have no idea what that looks like yet. The light from the present Andromeda won't arrive for another 2.5 million years. What we see is ancient, a memory from a time when the Earth was colder, when ice ages were beginning, when the creatures that would eventually become us were just starting to walk upright. That galaxy has changed since then. Stars have been born, stars have died, planets have formed. Perhaps life has begun somewhere, on some world circling some star we'll never know about. All of that has happened, but we can't see it yet. We're still watching the past, and Andromeda is close, relatively speaking. There are galaxies much, much farther away, galaxies millions of light years distant, tens of millions, hundreds of millions. The light from those galaxies has been travelling since before the dinosaurs, since before complex life existed on Earth, since the planet was still forming its continents, its oceans, its atmosphere. With powerful telescopes, we can see galaxies billions of light years away, galaxies whose light left when the universe itself was young, when stars were just beginning to form in large numbers, when galaxies were smaller, closer together, colliding and merging in ways they rarely do now. We see them as they were billions of years ago, not as they are. We have no way of knowing what they look like now. The light hasn't arrived yet. It won't arrive for billions of years. By the time it does, we'll be long gone. The Earth will be gone. The sun will have burned out. But the light will still be travelling, still carrying images of galaxies from a time we can only see, never touch. There's a strange comfort in that. The light doesn't need us to keep moving. It doesn't need anything, it just moves, patiently, endlessly, carrying the past across distances so vast that even the concept of distance starts to lose meaning. And all of it, the nearby galaxies, the distant ones, the ones so far away we can barely detect them, all of it is visible because light takes time, because we're always looking backward, always seeing what was, not what is. The deeper we look into space, the farther back in time we see, and the farthest we can look. The absolute edge of what's visible takes us back to the very beginning, to light that's older than galaxies, older than stars, light from the moment the universe began. We'll go there next, to the oldest light, the light that's been travelling longer than anything else, the light that shows us where everything came from. There is light all around us that's older than anything else we can see, older than the oldest stars, older than the oldest galaxies, light from the very beginning. It's called the cosmic microwave background, and it's everywhere. You can't see it with your eyes. It's not in the visible spectrum anymore. The light has stretched, changed, shifted into microwaves as the universe expanded. But it's there, filling all of space. A faint glow left over from the moment the universe became transparent. About 380,000 years after the Big Bang, the universe cooled enough for light to travel freely. Before that, everything was too hot, too dense. Light couldn't move far before being absorbed and scattered. But then, the universe expanded, cooled, thinned, and light could finally travel. That light has been travelling ever since, for 13.8 billion years. It's the oldest light in the universe. the first light that could move freely. And it's still here, still moving, still reaching us from every direction. When scientists point their instruments at the sky and measure this light, they're seeing the universe as it was 13.8 billion years ago. They're seeing the afterglow of the beginning, not the Big Bang itself, that's hidden, unreachable, but the moment just after, the moment when the universe took its first clear breath. That light has travelled farther than anything else. It has crossed the entire observable universe to get here. And it will keep travelling long after we're gone, long after the Earth is gone, long after the sun burns out and the stars fade. This light, the oldest light, will still be moving, still carrying the memory of the beginning, patiently crossing an expanding universe, reaching worlds and eyes that don't exist yet, showing them what we see now, a universe that was once small, hot, dense, a universe that has grown, cooled, spread out into the vast, quiet thing it is now. The cosmic microwave background doesn't tell us what the universe looks like today. It can't. It's too old. It left too long ago. But it tells us where we came from. It tells us that everything we see, every star, every galaxy, every planet, every bit of dust, came from that same hot, dense beginning. And that the light from that moment is still here, still reaching us, still arriving after all this time. There's something quietly beautiful about that. We're surrounded by the oldest light in existence. We can't see it, but it's there, touching us, passing through us, carrying a message from the beginning of everything, and we're here to receive it. Not because we did anything special, just because we exist. Just because we're here, in this moment, in this place, at this time when the light from the beginning is still arriving. We are living in the middle of a journey that started before anything existed. And that journey isn't over. The light will keep moving, the universe will keep expanding, and somewhere, billions of years from now, that same light will reach places we can't imagine. It will keep going, patiently, endlessly, the way light always does. So if all light takes time to travel, if everything we see is from the past, then what is now? What does it mean to exist in the present moment, if the present moment is never really what we see? This is one of those questions that doesn't have a simple answer. Not because it's complicated necessarily, but because the answer depends on how you think about time. For most of our lives, now feels obvious. Now is this moment. The moment you're in, the moment you're experiencing. It's the same for everyone, we assume. When something happens, when a bird flies past or a car drives by, or someone speaks, it happens now, and we all experience that now together. But that's not quite true. Not when you account for light. Because light takes time to travel, there's no single now that everyone shares. There's only the now you experience where you are. And that now is made up of light from different moments, all arriving at once. The light from your hand left a few nanoseconds ago. The light from the wall left a few billionths of a second ago. The light from the moon left over a second ago. The light from the sun left 8 minutes ago. The light from the stars left years ago, decades ago, centuries ago. All of it reaches you in the same moment. But none of it is from the same moment. You are standing in a place where the past, many different pasts, converge. And that convergence is what you experience as now. If you're looking at a friend across the room, you see them as they were a fraction of a second ago. If they were looking at you, they see you as you were a fraction of a second ago. Neither of you is seeing the other in the present. You're both seeing each other's past, and yet you feel like you're sharing the same moment. Because the delay is so small that it doesn't matter. It's close enough to now that it feels like now. But it's not. Not technically. Technically, the present moment, the true simultaneous present, is something we never actually see. It's always just ahead of us, always out of reach. We live in a world where the present exists but is invisible, where everything we perceive is history. Recent history usually, but history nonetheless. This doesn't mean the present isn't real, it just means we can't see it directly. We can only see its echo, the light it sends out, and by the time that light reaches us, the moment has already moved on. This is true everywhere in the universe, not just here. If there is someone on a planet orbiting a star 100 light years away and they look toward Earth, they won't see us as we are now. They'll see Earth as it was 100 years ago. They'll see the early 1900s, a world without most of the technology we have now, without most of the people alive now, a different Earth. And if we look at them, we'll see their planet as it was 100 years ago. Neither of us will see each other in the present. We'll both be looking at the past. And there's no way to fix that, no way to speed up the light or catch up to the present. The speed of light is the speed limit of the universe. Information, any information, including light, can't travel faster than that, which means the delay is built in, permanent, universal, everywhere across all of space. Beings are seeing each other's pasts. There is no shared now, only layers of past, arriving at different rates, depending on distance. The farther away something is, the older its light, the older the past we see. And since the universe is so vast, since galaxies are millions and billions of light years apart, the past we see when we look out into space is ancient. We're not just looking at distance, we're looking at time. The two are inseparable. To look farther is to look older. To see deeper into space is to see deeper into history. And the present, the actual true present of the entire universe, is something no one will ever see. It exists, but it's hidden, scattered across space, separated by distances so large that the light from one place will never catch up to another. We live in our own bubble of now, a bubble made of light that's already old by the time it reaches us, and that's okay. It doesn't make life less real. It doesn't make the moments we experience less meaningful. It just means we're always a little bit behind, always catching up to a present that stays, just out of reach. And maybe that's fitting, because we're always moving forward too, always creating new moments, new light, new pasts for someone else to see. Here's something worth noticing. While you're receiving old light from everything around you, light from the past, you're also sending out light, right now, in this moment. Light is reflecting off you, off your skin, your clothes, everything near you. And that light is travelling outward, into the room, out the window, into space if it makes it that far. It's moving at the same speed all light moves, and it will keep moving, for as long as there's space for it to cross, which means that the light reflecting off you right now, the light from this exact moment, will eventually become someone else's past. If someone looks at Earth from far enough away, they won't see you as you are now. They'll see you as you were, and the farther away they are, the older that version of you becomes. Someone on a planet 10 light years away, if they could somehow see you, would be seeing you as you were 10 years ago. A younger version of you, or maybe an older version, depending on where you are in your life. But not the current version, never the current version. Someone 100 light years away would see you from a century ago. Except you weren't alive then, so they'd see nothing, just the Earth. The planet as it was before you existed. And someone 1,000 light years away would see Earth long before any version of you was possible. They'd see a world you'll never know, a past that has nothing to do with you. But the light you're making now, the light reflecting off you in this moment, will eventually reach those places. Not in your lifetime, not in anyone's lifetime, but it will get there. In 100 years, that light will be 100 light years away. In 1,000 years, 1,000 light years away. Travelling outward, carrying an image of you from right now, an image no one may ever see, but it will exist, out there, in the universe, a piece of this moment frozen in light moving farther and farther from where it started. You are part of this constant exchange. You receive old light, you send out new light. Everyone does. Everything does. Stars, planets, galaxies, all of them are sending out light that will become the past for someone else. And all of them are receiving light from others' pasts. We're all standing in the middle of time, not at the beginning, not at the end, somewhere in between, surrounded by light from moments that have already happened, creating light that will become moments for others to see later. It's an exchange that never stops. Light moving outward in all directions, crossing paths, travelling through emptiness, carrying information from one place to another, one time to another. And we're part of it, not separate from it, not outside of it. We're in it, right now, receiving light from a billion tons, different pasts, sending light toward a billion different futures, standing still but also moving, always in motion because the light is always in motion. You can't stop it. You can't hold on to the present. It slips away the moment it happens, carried off by light, turning into the past before you even realize it's gone. But that's not sad. It's just the way things are, the way they've always been, the way they'll always be. Light moves, time moves, we move with it, whether we notice or not. And somewhere out there, far away, the light from this moment is still travelling, still carrying a piece of now into the future, where it will arrive eventually as someone else's past. Think about the light leaving you right now, not metaphorically, not poetically, literally. Photons are bouncing off your skin, your hair, your clothing. They're reflecting the light from the lamp or the screen or the window. And then they're travelling out into the room, through the air, some of them toward the walls, the floor, the ceiling, some of them toward the window if there is one. And if they make it outside, if they pass through the glass, through the atmosphere, they'll keep going out into space, away from Earth, away from the sun, into the vast, dark emptiness between stars. And they won't stop. There's nothing to stop them. Space is mostly empty, mostly nothing. So the light just keeps moving, year after year, century after century. The light from this moment, from you sitting here right now, will still be travelling 1,000 years from now, 1,000,000 years from now, 1,000,000,000 years from now, long after you're gone, long after everyone you've ever known is gone, long after the cities and roads and buildings have crumbled. The light will still be out there, moving, carrying an image of you from this exact moment. It might never reach anyone, probably won't, honestly. Space is unimaginably large, and the light spreads out as it travels, becoming fainter, harder to detect. By the time it's a few light years away, it will be so dim that even the most sensitive instruments couldn't pick it out from the background glow of the universe. But it will still exist, still moving, still carrying that tiny piece of information. You were here, in this moment, in this place, reflecting light. There's something quietly astonishing about that. You're not just living in this moment, you're sending this moment outward, into the universe, into the future. Every second of your life, light is leaving you and beginning a journey that will outlast everything you know. It's true for everyone. Every person who has ever lived has sent light out into space. Ancient humans sitting by fires, reflecting firelight into the night sky. That light is still travelling, thousands of light years away by now, carrying images of people who lived so long ago that we've forgotten their names, their faces, their stories. But the Kindu, light remembers, in a way, not consciously. Light doesn't think or remember, but it carries the information, it holds the image, and it keeps moving. The same is true for you, for me, for everyone alive right now. We're all making light, not creating it. We're not stars burning fuel, generating photons, but we're reflecting it, redirecting it, sending it on new paths, and some of that light will travel farther than we can imagine. Farther than we'll ever go. It will outlive us, outlive our civilizations, outlive our planet eventually. The light you're making now will still be moving when the sun burns out, when the earth is gone, when the stars we see tonight have faded and died. Your light will still be travelling, a ghost of this moment, a memory made of photons, moving slowly through the dark, forever, or at least for as long as the universe allows. You don't have to do anything special for this to happen. You don't have to try. It's automatic, unavoidable. You exist, and therefore you make light. And that light carries you outward, into the cosmos, into time, into futures you'll never see. It's one of the quietest, most overlooked facts of existence. But it's true. Right now, as you sit here, you are sending pieces of this moment into eternity. And that's something worth noticing, even if just for a moment, even if just once. There's no need to fully understand all of this. No need to solve it or figure out what it means or decide how it changes anything. It's enough to simply notice, to let the idea sit quietly in the back of your mind. The light around you is old. The light leaving you will outlast you. And both of these things have been true forever, long before you were here to think about it, long before anyone was here to notice. Light has been travelling this way patiently, endlessly since the beginning. It will keep travelling long after the end, whatever that end looks like. This is one of those truths that doesn't demand anything from you. It doesn't ask you to change or act or feel a certain way. It just is. The light moves. Time moves. We move with it. And the universe carries on, indifferent and beautiful, holding all of it together. The past we see, the present we live, the future we send forward. All of it connected by light. All of it unfolding at the speed light allows. There's a continuity to it. A rhythm. Not a rhythm you can hear or feel directly, but one that's always there. Steady, unchanging. The light from distant stars arrives tonight, the same way it arrived last night, and the night before, and every night for thousands of years. The light from the sun will arrive tomorrow morning, 8 minutes old, the way it always has. The moon will keep showing us its past, second by second, and we'll keep reflecting light outward into the future without even trying. This continuity doesn't depend on us. We're part of it, but it's bigger than us. Older than us, it will continue without us, and somehow that's comforting. The universe doesn't need us to keep going, but while we're here, we get to witness it. We get to look up and see the stars. We get to notice that the light is old. We get to feel the warmth of the sun, knowing it left 8 minutes ago. We get to sit quietly in a dark room and realize that everything we see, everything is a message from the past. That's a gift, in a way, not a dramatic gift, not one that changes anything, just a quiet awareness, a small piece of understanding that adds a little depth to the world. The light will keep traveling whether you think about it or not, whether you notice it or not. It doesn't need your attention, but it's here, and you're here, and for this moment, you can notice it together. The ancient light, the patient light, the light that's been travelling so long just to reach this place, this moment, your eyes. And that's enough. Let's come back now, back to where you are, back to this room, this moment, this quiet space. The light here is gentle. Maybe it's from a lamp, maybe it's from a screen, or the last glow of evening coming through a window. Whatever it is, it's here with you. And now you know something about it that you didn't before. Or maybe you knew it, but hadn't thought about it in a while. The light you're seeing left its source a moment ago. a tiny moment. Almost nothing, but a moment nonetheless. It travelled across the room or through the window, or from the bulb to your eyes, and in that travelling time passed. Not much, but some. You're seeing the past, even here, even now, even in the smallest, quietest spaces. And that's okay. You don't have to do anything with this knowledge. You don't have to remember it tomorrow or think about it again. It's just something that's true. Something that has always been true. The light around you is ancient and new at once. Ancient in its journey, new in its arrival, and you're here to receive it. Not because you did anything special, just because you're here. Just because you exist in this moment, in this place where light from a billion different paths converges. Outside, the stars are still shining, still sending their old light toward us. The moon is still glowing a second behind itself. The sun will rise again tomorrow 8 minutes late the way it always does, and you'll be here. Or somewhere else, receiving light, reflecting light, part of the endless exchange. There's no rush to understand it all, no pressure to hold on to this feeling or this thought or this moment. The light will keep moving, the universe will keep unfolding, and you can simply rest here, in the quiet, in the stillness, surrounded by light that has travelled so far for so long just to reach you. You can close your eyes now if you'd like, or keep them open. Either way, the light is still here, still moving, still carrying the past into the present and the present into the future. And you're part of it, always have been, always will be, for as long as you're here. If you'd like to stay a while longer, we'll be here. Making more quiet journeys, more slow observations, more gentle noticing. You're welcome back anytime. There's no rush. The light will wait.